Gold nanoparticles are one of the most significant noble metal nanoparticles due to their extensive utilization in several versatile applications. Their distinct optoelectronic properties, low toxicity, excellent biocompatibility, high stability make them ideal candidates for biological, biomedical, diagnostic, sensing, and several other applications. Different methods of gold nanoparticle synthesis have been categorized majorly into physical, chemical, and biological methods. The chemical reduction based Turkevich method of gold nanoparticles will be demonstrated in this video. This method involves two major components. The first one being the precursor metal salt HAUCl4, that is tetrachloroauric acid, and the other being the reducing agent Trisodium citrate. This acts as the reductant as well as a stabilizer to reduce the precursor salt HAUCl4 into gold nanoparticles. A list of chemicals and apparatus required for the current experiment have been listed herewith. We require tetrachloroauric acid as the precursor salt, trisodium citrate as the reducing agent, magnetic stirrer with heating, thermometer, weighing balance, pipette, standard flask, amber storage bottle, round bottom flask, and magnetic beads. The first step involves the preparation of the reagents. Separate clean and dry spatulas and butter sheets are taken for weighing the chemicals. The two major chemicals required are the reducing agent trisodium citrate, that is prepared in the concentration of 2%, and the precursor salt HAUCl4, that is prepared in the concentration of 1 millimolar. Preparation of the precursor salt solution tetrachloroauric acid. To obtain 1 millimolar HAUCl4, accurately weigh 39.2 mg, that is 0.0392 grams of HAUCl4 in 100 ml of water. This is stored in dark brown amber bottles to protect them from light. Preparation of the reducing agent trisodium citrate. To obtain 2% trisodium citrate, carefully weigh 2 grams of trisodium citrate and add it to a 100 ml standard flask. This is made up to the mark using deionized water. It has to be shaken well for complete dissolution. Once both the reagents are ready, we can head towards the experiment. Synthesis of gold nanoparticles. For this, a round bottom flask is firmly fixed on the stirrer using a stand. Now 25 ml of the precursor HAUCl4 solution is added to the round bottom flask. A small clean magnetic bead is added to the flask. The heating knob is turned on to the desired temperature and the flask is stoppered to avoid evaporation. The reaction can be observed and it is left undisturbed till the solution reaches the desired temperature. A thermometer is used to monitor the temperature of the reaction. Around 10 to 15 minutes later, the temperature is checked and by now it reaches 100 degrees Celsius. Once that is confirmed, the 2% reducing agent trisodium citrate is added to the reaction solution. An electronic pipette of 1 ml calibration capacity is used for the addition. 3 ml of 2% trisodium citrate is carefully added dropwise to the reaction solution using this pipette. A mild color change can be observed with the slow addition of the reducing agent. This is followed by the appearance of a blackish color, and the solution is further continued to stir After a while, we can slowly observe the solution to change into a brownish red color, finally turning into bright ruby red color. The final colloidal solution is allowed to stir for a while. Once the reaction is completed, it is carefully transferred into a clean glass storage container and stored under refrigerated conditions. Finally, the gold nanoparticles have been successfully synthesized. The formation of this ruby red color is the characteristic color indication confirming the formation of gold nanoparticles. These gold nanoparticles exhibit a UV spectrum in the wavelength range of 500 to 580 nanometer. This can be clearly observed in this image where a distinct clear peak is seen at 520 nanometer. This UV peak wavelength depends upon the size and the color of the synthesized nanoparticles.